Simplify these expressions. So we're going to take this, set it equal to x is just a review problem. We have the log is base 6. So the base of our log becomes the base of our exponential. So it's 6 to the, what is a log? A log is an exponent. 6 to the x equals 6 root 6. Now we have our exponential equation. We need to get one base on each side. This is 6 to the first power times 6 to the 1/2 power. We have two things that are multiplied together with the same base, so we can add the exponent. 1 plus 1/2 is 3/2. Now we have two exponentials that are equal with the same base, so x equals 3/2. Similarly, set the next one equal to x. What's our base this time? 32. Again, a log is an exponent, so 32 to the x equals 8. This time we have to get it so they have the same base. What can you write 32 and 8 as from the base of 2? So it's 2 to the 5x equals 2 cubed. 5x equals 3, because again, two exponentials are equal with the same base, so 5x, their exponents are equal, and x equals 5/3. Can you do this next one without thinking about it? We've done this, I did it in the last video. I think we had actually two of them there. So we have 9 to the x equals 1, x equals 0. And we're going to end up building on part D here soon, but can you answer this one without? You can think about that. What's the base of the log? It's base e, so it's e. A log is an exponent. E to the x, remember ln is just a log base e, equals e to the 5. So the same base, x equals 5. All right, this next one's going to be a little bit more challenging. We're given this log of 6.92 is approximately equal to 0.8401. And what this tells us is that what's our base of that log? 10. So 10 to the 0.8401 is approximately equal to 6.92. We're going to need that when we do this. So our initial process will start out the same. And we'll have 10 to the x equals 69.2. Now compare that to what we know. We know this expression or this equation. That 69.2 is very similar to that 6.92. So let's write it as 6.92 times 10. Why do we want to do that? Because we want to put it into a form similar to what we just did in 1a, where we have the same base for all of them. We know 6.92 is 10 to the 0.8401, and now we have times 10 to the 1, and this really becomes an approximate because this is an approximation. Now we have the same base there, so we have 10 to the 1.8401, and so that tells us that x is approximately equal to 1.8401. Try to do B and C on your own, and then take a look. Pause it, and then come back. All right, we're going to set it equal to x. We'll have 10 to the x equals 692. That is 6.92 times 100. And we have 6.92 is 10 to the 0.8401. And then 100 would be 10 squared. So we have 10 to the 2.8401 equals 10 to the x. So therefore, x is 2.8401. Let's do the last one. And that is similar. Again, it's going to be a slight variation of it. This time we're going to have 6.92, and we're dividing it by 10. Well, how can I write that? That's the same as 6.92 times 1 over 10, which is the same as 10 to the negative 1. Now I can do my approximation. 0.8401 times 10 to the negative 1. We add the 2, so we have 0.8401 plus negative 1, and we'll get 10 to the negative 0.1599. So that's going to tell us x is approximately equal to negative 0.1599. So of the ones we've done thus far, these ones are the hardest ones. But as you can see, they're not too bad. They're still using those same ideas. Now let's go on to the next one. When we see a graph like this, what we want to do is should recall what we did back in chapter 4, the transformations. They're dealing with this graph of ln of x, and actually let's just sketch them. What I want to start with is y equals ln of x. We should know this graph. That graph is the inverse of our exponential, and we graphed that one in the previous section, and this is 1. Now, when we look at y equals negative x, let's say that f of x equals ln of x. This is looking at negative f of x. What does negative f of x do to the graph? Well, it's going to reflect it about the which axis? What is the negative affecting? It's affecting the y numbers. So all the positive y numbers become negative and the negative become positive. So that's reflecting about the x-axis. So it's the same graph, just reflected over. And we have that. And let's label it as y equals negative ln of x. And I'll get out another one, and this time we're applying an absolute value. What does the absolute value do to the graph? It takes all the negatives and makes it positive. What does it do to the positives? Nothing. So what we're going to do is the positive part here of this graph is going to stay the same. And the part that was negative is now going to flip up and be positive. So it's going to be right on top of there. And this section will be y equals absolute value of ln of x. Now the next part says, what's the range of each? The domain, even though it's not asked, that one's not too bad. It is all the numbers that are positive. Now when we look at this, the negative ln of x, we're going up to positive infinity, and here's going to be going down to negative infinity. So let's write here negative ln of x. The range would be y such that y is an element of the set of real numbers. And when we look at y equals the absolute value of ln of x, we have y such that y is greater than or equal to 0. All right, the next ones. We're going to simplify. We haven't done these problems, these kind yet. What we're going to do is set it equal to x, just like we did before. Now there's going to be a variation here. Now this looks kind of complicated because we have an exponential and a log and the whole thing. Let's take this for just one moment and let a equal log base 2 of 8. So we have 2 to the a equals x. Now let's take that exponential and transform it into a log equation. So the base of the exponential is 2, so it's going to be log base 2. And remember, a log is an exponent, so this is going to equal x, and it's log base 2 of x. There's going to equal a here. So now let's bring back what a is. So it's log base 2 of x equals log base 2 of 8. We have two logs that are equal, and they have the same base. Well, the only way that's going to be true is if their argument x equals 8. Now I'm going to do this one slightly different this time. Instead of doing this substitution, and you can do that, what I want to do is just think of it, what happens when I cover up the exponent? So I'm going to say 5 to a power equals x. And I'm going to take this exponential form and I'm going to transform it into the log. So the base is 5, so it'll be log base 5 of x equals my exponents. And what is my exponent? It doesn't matter how ugly it is, I'm just going to write it down now. Log base 5 of 25. Now we have two logs with the same base, so their arguments are equal. X equals 25. Now, when we do it on this one, I can't use x because I have an x here, so I'm going to use a. So again, cover it up. my base is 3, so it'll be log base 3. In fact, I should write that a little bit smaller. Of a equals what my exponent is, log base 3 of x, or in other words, a equals x. That one's related to what we had just done in a previous problem. All right, let's go on to number 5. If f of x equals 3 to the x, what is f inverse of x? Remember our process for that. This is a good review of chapter 4. We're going to let our f of x be y, and so it's y equals 3 to the x equals 3 to the y. Now we have to solve this. This is an exponential equation, and I need to transform it so I can get this y out of the exponent. I'm going to transform it into the log, and so the base is 3. Log base 3 of x is going to equal my exponent of y. Or in other words, f inverse of x equals log base 3 of x. Now it says to find f of f inverse. So f of log base 3 of x, and that would be 3 to the log base 3 of x, and that's what we just did in 4c. That is x. Let's do the same thing for the next one. Y equals e to the x equals e to the y. Transform that. This would be log base e of x equals y. So f inverse is the natural log of x. Let's come over here and do the same thing. F of the natural log of x equals e to the ln of x. And if we go through that same process that we just did in the previous one, we can say let it equal x. So this would be log base e of a equals ln of x. And log base e is the same as ln, so this simplifies to x. Now my question is, why? Why do both of them both equal x? Recall back in we had this statement, if f of x and g of x are inverses of each other, then f of g of x equals g of f of x equals x. For all x in the domain of g for this one, and all x in the domain of f for this one. All right, next one. Solve without using your calculator. Transform this. We have 4 is our base of the log, so that's going to be base of our exponential. Log is an exponent. 4 to the 1.5 equals x. Now, how do I simplify that without using my calculator? This is the same as 4 to the 1 plus 0.5. Now, if I undo the adding of the exponents, this is 4 to the 1 times 4 to the 0.5, which is 0.5 is 1/2. That's a square root. What's the square root of 4? 2. So that gives me 8. And on the next one, the base is e. So it's going to be e to the 2.5, because that's what our log equals. That's our exponent, equals x. And with that one, we're done, because if we don't have a calculator, we can't do anything else. All right, getting towards the end here. We have, this time we're going to use the calculator. We have log. It doesn't say what our log is, or what the base is, so you have to know. Remember, that's a common log, so it's base 10. So it's 10 to the 1.5 equals x. So just turn on your calculator, 10 exponent 1.5, and that gives us 31.62 is our approximation. We're going to go about the next one similarly. The base is e, so it's e to the negative 1.5 equals x. And then just type that in. Remember, e is with our ln button. So we're going to press second, and then press that ln, which is 2 keys above the on key. And then just type in negative 1.5. Remember, negative is below the 3. and we get point x is approximately equal to 0.22. All right, the last one. Another application of logs is dealing with sound. We have, here's the expression on how to find what the decibel level is, and so we'll apply it to these things. So we'll have 10 log of, for average car at 70 kilometers per hour, it gives us I is 10 to the 6.8 times I sub 0, which is, we'll put that in, 10 to the 6.8, because we're going to plug it into this spot, times I sub 0, divided by I sub 0. So we get 10 times log of 10 to the 6.8. And how do you go about doing that one? Well, I want to deal with just this piece. Log of 10 to the 6.8, if we set it equal to x, the base is 10, so 10 to the x equals 10 to the 6.8, or in other words, x is 6.8. So we get 10 times 6.8, which is 68. So that would be 68 decibels for that. And on this one, we'll have 10 log of 10 to the 1.5 times I sub 0 divided by I sub 0. We have 10 times the log of 10 to the 1.5. If we go through this exact same process again, what is log of 10 to the 1.5 going to give us? It's going to give us 1.5. So 10 times 1.5, and that gives us 15 decibels. And that is all.